this paper is written by Pennington and others. This is available again for you to read. There is a very small section for analogy computation in this case, especially for the global vector or the GLOW model. It is about 1 or 2 paragraphs. I would like you to go and then read that. So, they use that as a downstream application to prove that a GLOW model really solve the analogy problems. Okay. Okay, so now let us get into the higher level details of what GLOW model is. Again, this paper is about 8 pages long, okay, except for the derivation of how they really construct the cost function. The rest are very easy to follow. So, if you read that section, the third section where they talk about the GLOW model, you will understand how the cost function is constructed, and then how they really use that cost function to find the word vectors. So, I am only going to give you a very high level overview of this, all right. Okay. So, in this case they introduce the idea of co-occurrence ratio between the two words, which we had not seen earlier. So, what we had seen earlier is only the co-occurrence count and then the correlation computation for 2 words, and then finally we build the table, right, in both in the HAL model where we utilize the count, in the Coles model we utilize the correlation, right. So, there is a definition that you may have to understand. So, this is the probability of the word J appear in the context of word I is what we are finding. So, we are introducing the concept of probability in this case. Okay. In this case we are going to be utilizing the statistics of the co-occurrences, or how often the patterns occur together. So, which skip-gram model failed to utilize. So, to understand the particular slide here, you need to first go to the examples that they have given. Okay. So, they have given 4 classes, let us say solid, gas, water and fashion, and then they have the probability computation for given the i's, what is the value for this probability, okay, when k is equal to solid or gas, water or fashion. Okay. So, they use the same kind of the corpus. In this case I think they are utilizing a very big corpus and then try to find out the values for each of this. Okay. So, to find the probability, so you need to find out the xij. Xij represent the number of times the word j occurs in the context of word I. Okay. And then xi is equal to sum of xik, where xi is the number of times any word appears in the context of the word I. So, you take any word and then how many times any word appears in the context of that particular word is what you are computing for xi here. Okay. And then probability uses those 2 values, which is defined as the probability that the word j appear in the context appear in the context of word I. Okay. So, this is what is being computed here, right. Using the corpus we can compute these values. So, what also they are suggesting is, if you want to really distinguish the meaning of 2 words, this is not just enough. You can also take the ratio of these probabilities that you have here. Okay. So, let us first find out what this one is. So, as I mentioned earlier, we have 4 classes, and then the values are found using the corpus. Okay. The probability of solid given ice is this number. Okay. And then you replace that with gas and you get this number. You replace this with water, you get this number, and then you replace this with fashion, which is not connected to this. So, obviously, this is going to be a very small number, right. So, when it is very close, right. So, when k equal to solid, you have a higher value, and given the ice, it cannot be a gas, right. So, this is going to have a small value, and then this is also going to have a value higher than this in some cases because of the occurrences, and definitely this is not related to this. So, you have a very small value. So, in the same fashion you find it for all. Okay. And then you also try to find out the ratio of the probability. For example, if you look at this, since this is going to be very small, we are going to have a very high value for that, right. And then again for the second one, it is going to have a very small value. Some of them which are not related to that could be having a value closer to 1. So, that means it is possible for you to distinguish ice and steam easily in this case. Semantically, you can separate them out, right. So, when compared to the raw probability, the ratio is able to distinguish relevant word solid and gas from the irrelevant word water and fashion. Okay. So, in this way you would be able to distinguish 2 different sets of words. So, that is what they are trying to prove by providing this example. All right. Since the ratio that we are talking about depends on 3 words, right. So, we have ice, steam and solid, correct. So, it depends on 3 words. It can be modeled using a relationship. We are going to be estimating a model which actually tries to get this ratio. Okay. So, what we are computing is only this, correct. So, we have the value given, but we do not know what created that values. Let us say like this. So, if you know, see for example, in the case of 5 plus 5, it is 10, it is very easy to figure out, but if you are not given this. So, there are so many different possibilities by which you can obtain 10. So, what is the right model that gives you this 10 based on various measurement that we have using the statistics, we should be able to estimate that particular model, then that is what these authors tried to figure out. So, what they did was they created a cost function that depended on bias values and the word vector. So, these are the 4 parameters that you are going to be estimating, and these values are available from the corpus. Okay. And then they also have a weighted function f of x I, and then they also define the weighted function as follows, as given in this equation 3. And then they also have given the value as x max equal to 100 and alpha equal to 0.75. So, there is no reason why only these values are picked, but they found that these two values really are giving an optimized vector set. Okay. So, that is why these two values are chosen. There is no theory behind these particular selection of values. Okay. So, in this case the authors are trying to minimize this function, and theta so these 4 parameters that you want to estimate using this particular model. Okay. So, the algorithm tries to minimize this cost function, and then initially these values are randomly chosen. As we progress, based on the values that we obtain from the corpus, we keep improving these values, and then when it is closer to the minimum we stop the iteration, or if it is here at the end we stop the iteration process. Okay. Let us look at what they have chosen as their corpus. They have tried with 3 different corpus. One is 2010 Wikipedia dump, which is about 1 billion tokens, and then they have used 2014 Wikipedia dump with 1.6 billion, and then there is one called gigaword 5 that contains about 40 plus billion tokens, and then they utilized a common crawl of the web, and then used 42 billion tokens to train this model. Okay. And then they have chosen close to 400k frequent words as vocabulary. I started with the initial value of 0.05 as the learning rate, and then they used ADA grid as a mechanism to change the learning rate as they move along. And then the context words to the left is considered, and the context word to the right also is considered in this case. They get 2 word vectors as in the case of Hal, Cole, as in the case of Hal and Cole, and then the final word vector is chosen to be the sum of those 2 vectors. And then they have shown through their results that this performs better than any other model. Say they used SVD, okay, using a log, and then they also used a square root of the Xij for SVD computation, and then try to find out how good their model is with respect to various other models. So, in this case there is one more which I have not discussed, which is again the latest, which uses the PMA version of the LSA to find the word vectors, and then there are 2 other models which are log bilinear models apart from what we had discussed earlier. They tried all those models and then tried to compare GLOV with this. They started with 100 dimension vector, and then the accuracy of their word vector is about 60%. Okay. And then they used a 300. If you look at this, as in every paper, you will see their model performing better than any other model. So far at this point in time, GLOV is supposed to be giving the best word vector, and then their word vectors are also available for you to pick up and then use.